This week, we're covering the Nobel Prizes, and we wanted to do our predictions, the one everyone actually cares about.
Yeah.
Not really. Physics.
Physics.
And so, what are you thinking?
Topological physics, okay? Topological physics is the study of geometries and symmetries, usually at the quantum level, that lead to phenomenon that are robust to poking and prodding. Okay? For example, a donut and a coffee mug.
Okay.
Topologically, they're the same, even though they look very different. And the reason for that is, imagine a donut made out of Play-Doh.
Yes.
I can squish and deform it into a coffee mug.
Okay.
Smoothly. I don't have to rip. I don't have to sew anything together. Why? Because the coffee mug has a hole, which is the handle.
Yes.
And the donut also has a hole. So I just need to take one right side of the donut and then make it into a mug. Fundamentally, what that means is any smooth deformation is not going to change that topological part.
Yep.
There, we've got a Mobius strip, right? On the left-hand side is just a ribbon.
Yes.
And if you've ever played around with Mobius strips, if you cut a Mobius strip, you're not going to get rid of the twist.
Yeah.
Right?
Right.
The ribbon, no matter what you do, you can't turn into a Mobius strip unless you cut it and you do the twist and you sew it back together, right? There are several phenomenon in physics that resemble the mathematics of a Mobius strip. With a ribbon, if you go in one direction, you're still on the same side.
Yes.
In a Mobius strip, you go around the circle, you're actually on the opposite side. So there's like a flip in the sign in some way of your orientation, right? Because it's going around, but now you're on the inside.
Yep. Yes.
So you're in the same spot,
Right.
but there's like a change that's happened.
Yes.
And you can't get rid of it, right? You know, in Marvel Endgame, I don't one of the coolest things for me was when Iron Man was figuring out like how to do the time quantum watch thing, and he was like, and he was telling Jarvis like, we're gonna put it on a Mobius strip, and I was like, he's using topological physics. I don't know about time travel. Okay,
for sure.
But it can get really important in finding different classes of topological insulators. There's quantum qubits that can be made out of topological physics, like the one from Microsoft.
Yeah.
There are three individuals who I think sort of laid the foundation for the theory. Michael Berry, he's known for the Berry phase, which is exactly this idea that I was talking about, where it's like you go around to the same spot, but like this phase has an offset.
Right.
There's also Yakir Aronov, who is famous for the Aronoff bomb effect, which is Eric Weinstein talks about it all the time. Alexei Kitaev at Caltech. I'm less familiar with his work. I've heard his name in spin liquids and things like that.